Okay. The difference of squares. I do want you guys to spend some time memorizing that phrase, what it means, what the work is to complete the problem. Difference is a fancy word for subtraction. Squares means that you have two things in the problem that are squared. So when you look at this one, really you could think of this as x squared minus 4 squared, right?
Yeah.
Now, in the quadratic, when you have two factors and you FOIL, the O and the I go together for the middle term, correct?
Yeah.
When you see x squared minus 16, what's missing? The x term, right? X to the first power term, that's the OI. So what that's telling you is that those two numbers, one's positive and one's negative. So just by looking at this, all this information should just flood your brain. So, 1 in front again. So it's just x and x. What are two identical numbers that multiply to give me 16? Or you've already done this kind of thought process, it's a 4. How are they going to add up to 0 for the OI?
One's positive, one's negative.
The negative 16 tells me one must be positive and one must be negative. That's the difference of squares factoring. Okay. Now, again, you want to recognize this situation. This only works when it's subtraction between the x squared term and your constant term. It doesn't work if there's addition there. It doesn't work if the x is in here. Only in this situation. So mathematically we call it difference of squares. What's being squared when you look at 64?
8.
X minus 8, x plus 8. What's being squared when you look at 1?
1.
X minus 1, x plus 1.
You have to put in the parentheses, you can't leave it like that thing up there.
Good, good. Sometimes, hang on, hey, sometimes they give it to you in what you think is the wrong order, but it doesn't matter. When you see 25, what's being squared? 5. So it's just a different direction.
Wait, we have to write it like that?
Yep.
Why are you writing it as mine?
So now on number 5, what happens is, this is the first time our leading coefficient has changed. The leading coefficient now is 81. But for a difference of squares problem, it doesn't matter. If we have all 3 terms and I change the leading coefficient, then it makes your life harder. But here it doesn't. So just think about what's happening. 81 is also, now when you look at this, you have an x squared, an 81, and a 49. They're all things squared, right? So how do you get 81? 9. So let's write 9x and 9x at the front. I mean, if it's not a perfect square, yes, you have more work to do, but when you see this difference of squares pattern, you see if it works. Then you can put your 7 and 7 in there. 1 positive, 1 negative. Number 6. Bunch of stuff happening. We actually have 2 variables, x and y. What times itself gives you x to the 4th?
X squared.
X squared. Good. And then when you look at the 25y squared, what can you split that up into? 5y and 5y. One positive, one negative. Now, if you are really paying attention, we have another perfect square in that problem. That's x squared minus something. So, how are you going to get x squared? X and x. What times itself gives me 5y? So now that second number is not nice, right? When that second number is not nice, just put it inside a square root. Because the square root of 5y times the square root of 5y, that's something to the 1/2 and something to the 1/2, right? When you multiply, what do? You add their exponents. So what's 5y? What's 5y to the 1/2 power times 5y to the 1/2 power? It's 5y, add the exponents. 5y to the first. So when you take the square root to the square root, you get right back to what you need. Make one positive, make one negative, can't do anything there. Now that is really the craziest one we'd ever run into. But if that second number, if you see it as x squared minus something, you can write it as a difference of squares. If that's not a nice number, just put it in the square root both times, and it will work. Next one. What you need to understand is ultimately x squared plus 4 x squared means you're dealing with a U-shaped graph. Eventually what we're going to do is take all the different factors that we've come up with and solve them by setting them equal to 0 and seeing where the parabola touches the x-axis. X squared plus 4 is a U-shaped graph of parabola shifted up 4. Does it touch the x-axis?
No.
No. So this thing will not factor, will not have solutions to it. So remember x squared plus 4, we're not working on the sum, right? The sum of squares. We're working on what's called the difference of squares. Minus, subtraction. So when you see this, that won't work. So we're done. There's no factoring. At least not yet.
Dun, dun, dun.